Hi guys, just one more video from lesson 10.2, and in this one we're going to do problem number 9, because in this one we're trying to find the area of a regular dodecagon, a 12-sided polygon, which is going to be a little more involved than doing a much simpler hexagon. Recall that hexagons are simple because of the 30, 60, 90 triangle relationships that are carved out here from that central angle. Dodecagon is going to be a little bit more work. We're going to actually have to use some trig, some SOHCAHTOA trig, to figure out our apothem. So let me guide you through that. Here's number 9. Okay, so we're told in number 9 that regular dodecagon, so n is 12, okay? And its number of sides is 12, all right? And we're given that a side length is 5, all right? So rather than go ahead and draw out the whole dodecagon, because I don't want to draw a 12-sided object that wouldn't look very good, I just gave the hint of it here, and here's one side being 5, okay? Remember that our formula for the area is 1/2 the apothem times the perimeter. So we know the perimeter already. If a side is 5 and there are 12 sides, the perimeter is 60, okay? Keep that in the back of your mind, okay? All right, now we're going to kind of go on and embark on a journey to find the apothem, okay? So remember, here's how you have to do that. You need to start by getting the central angle, okay? And you need that so you can get half the central angle so you can work out this triangle right here, which will ultimately lead you to the apothem. All right. So let's do some simple calculations, okay? The central angle is always worked out by 360 degrees divided by the number of sides there are, which is 12 in this case, right? So our central angle here is going to be 30 degrees, okay? Now from here, what I like to do is I'm going to actually erase this picture here and blow up just this right triangle here so we can work out the apothem and you can see the trig involved in that. So let me erase that and we're going to enlarge that triangle. And usually on paper, really all I sketch out, I might sketch out the whole shape, but really what's important is that little bitty triangle right there. Okay, so remember that if the central angle was 30, this angle here is 15 degrees. Okay, I hope that makes sense, because remember the central angle is from segment to segment going vertex to vertex. This will just be half that, okay? This angle here will be half that 30, so that's 15. This is 90. Okay, this would be 75, but you're not going to need that, okay? Remember, this is your apothem, and that's the thing you're trying to find. Now, if the whole side length was 5, then this guy here is 2.5, right? Okay, so now we have to use trig, okay? No 30, 60, 90 shortcuts we can do here. We have to use trig. So think SOHCAHTOA, right? Which trig function are you going to use? You got 15 degrees here. You got the opposite leg and you've got the adjacent leg, so that's going to be tangent, right? So here's how we set up for our apothem. We're going to say the tangent of 15 degrees is opposite 2.5 over the adjacent, which is A, the apothem, right? When we do the algebra here to isolate for A, I'll do it here on the board here. We're going to multiply both sides of the equation by A. That will get us A times tangent of 15 degrees equals 2.5, and then we're going to divide both sides by tan 15. Okay, I'm going to erase some stuff so we can reset here. A is going to be 2.5 over tan 15, right? So let me erase that. Hope you followed so far. Okay, the apothem is going to be 2.5 over tangent of 15 degrees. Now, here's the important thing in terms of finishing this problem. Don't punch that in on a calculator just yet, or at least don't punch it in and round it. At least that's the worry, okay? That will lead you to a slightly inaccurate answer at the end, okay? Keep that as it is, and keep that's your apothem right there. So you punch in on a calculator, just use that expression, okay? So recall, here's our formula for the area, right? 1/2 times the apothem times the perimeter, okay? So when you're plugging in here, you're just gonna go 1/2 times your apothem, okay, 2.5 over tan of 15 degrees times the perimeter, which is 60. So if you want, on your calculator, maybe go 2.5 over tan 15 first, and then multiply all that by 30, right? Half of 60 would be 30, just multiply all that by 30. You'll get your answer, and the answer, I believe, comes out to 279.9 meters squared. Okay, I'll trust that you can work that out from there, but 279.9 meters squared is what you should get. Hope that helps. Thanks all. Bye.